So today we are going to be talking about AI-powered ADEM and the benefits it offers. Now, when I use the word ADEM, I'm referring to Autonomous Digital Experience Management. This is a solution that has been available for the last 2 years. Now, we've introduced AI capabilities on top of ADEM. So I want to talk today about the new capabilities that we've introduced with ADEM and how they are enhancing visibility and resolving help desk and IT challenges for enterprises. First, let's look at some of the top challenges that enterprises face when it comes to resolving user experience issues or network issues. First of all, multiple point products are being used today by several enterprises. There is no one solution that offers end-to-end visibility into user experience issues. There is a separate solution for managing endpoint devices, a separate one to troubleshoot service provider issues, and a separate one to troubleshoot cloud security infrastructure, and then another one for application performance issues. Now, all of these solutions provide different kinds of insights to the network administrator, and it is up to the help desk or IT or the network administration team to correlate all of these insights and come up with a meaningful inference. Now, the challenge here is there are several events and insights that are generated by each of these solutions. First of all, the administrator has to get to the root cause in each of these solutions and has to identify a pattern and find out if there are other causes that are contributing to the performance issues. So basically, there is a lack of correlation, and a lot of man hours are wasted in trying to identify where the problem lies. And what this really means is lack of productivity for the enterprise because the user is blocked until this problem is resolved. Now, we were also talking about the lack of correlated insights and requiring multiple point products, right? So where all are we using these point products, and where all do enterprises have these visibility challenges today? So if we look at a user coming from the branch, we need insights into the user's endpoint device performance. And the user could be bringing in any device. It could be a BYOD device. So irrespective of whatever device the user brings in, we need to make sure that the user's experience and performance is continuously monitored. And then the user's Wi-Fi segment. So this is one of the most popular reasons, especially with the hybrid working environment that we have. I have personally observed that a lot of customers get complaints for user experience issues because of compromised Wi-Fi signal strength or because of their home router. And having the visibility into these two segments is essential because, first of all, these two segments lie within the user's home network. So the user is likely not monitoring these services. So it's very important to proactively get the telemetry from these segments in order for the network administrator to provide valuable insights back to the user, historical trend data, to tell the user that, hey, this is what is happening with your Wi-Fi. This is what is happening with your LAN segment. Why don't you do this to go and fix the problem that you're experiencing? So the lack of historical trends, the lack of actionable insights from all of the segments within the user's home network. Now, coming to the infrastructure services, there are not enough insights there as well because we are looking at multiple teams working on these infrastructure services and multiple solutions that are required to monitor these services. Example, the authentication server, the DNS, the cloud security infrastructure, for the data center connectivity. So for all of these services, there is no single tool that is available to monitor the entire enterprise infrastructure. So these are all the visibility challenges that enterprises are facing today. Now, with AI-powered ADEM, we offer observability with autonomous digital experience management, and the AI ops capabilities provide deep, granular insights to identify where the problem is happening. So we are going to be looking at all the AI ops techniques that we are using today, all the telemetry that we are collecting and how this considerably reduces the mean time to resolve a problem for enterprises. So this is to show how with AI-powered ADEM, all the visibility challenges that we just saw for enterprises are all resolved. So all these green icons that you see are all the telemetry that we get from AI-powered ADEM, and with the baselining anomaly detection capabilities that we have, we are able to instantly identify where the problem is. We are able to continuously monitor the problem and alert and notify the network administrators whenever the problem status changes. This is to give you a quick overview of where AI Ops fits in a license tiering. So all of our customers have access to Prisma Access Insights. It comes with the Prisma Access base license. So it provides details like the health, connectivity status, and usage of the Prisma Access infrastructure. Now, on top of Insights comes the ADEM license, the Autonomous Digital Experience Management, which offers visibility and collects telemetry from the different segments and vantage points from across the enterprise. Now, on top of ADEM is the ADEM AI Ops license, which provides quick resolution of issues both in the user segment and in the infrastructure with additional monitoring that we offer, and also with additional AI-powered capabilities like baselining, anomaly detection, and remediation playbooks, predictive analytics, event correlation. All of these capabilities are added on top of ADEM observability. So that is ADEM AI Ops for you. Now let's go through a demo and I'll show you how exactly AI-powered ADEM helps with the faster resolution of issues across the enterprise. What you're looking at here is the Sassy Health dashboard. So this dashboard provides a bird's eye view of the global distribution of users across the enterprise. So what you're looking at is regional clusters of users who are connected to Prisma Access. And you're also looking at the performance distribution of users across these regional clusters. So the cluster where I've highlighted, there are around 1.4K users who are connected. And of these users, 1.2K users are having a good experience, which means their performance is not compromised. They are users who are having a very productive day. There is nothing that is blocking their access or limiting their performance. But around 400 users in this cluster are having a degraded experience. Now, as a help desk engineer or as an IT engineer, this is where I want to focus. I want to know where this degraded experience is coming from. So when I click on this 400 users, it gives me a distribution of these users, and there are drill down workflows to understand why these users are having a performance impact. Now, say for example, if a group of users are experiencing some kind of performance impact due to service provider, let's say the US West region is having a service provider brownout situation or an outage. When I look at this map, when I log into the health dashboard and look into this map, I would instantly see that regional hotspot. I would see these users in the US West region are highlighted in red and they are having some kind of performance impact. So I'm drawn immediately to where my attention should be. I'm drawn to the focus areas for a network administrator. So this gives a very clear high-level bird's view of the organizational performance summary. Now, like I mentioned, I want to know why my users are having an impacted performance. That's my number one question as a network administrator. How do I get that information? So on the global mobile user tile, I click on the impacted users. That's number 400 users who are having a potential degraded experience. And what this shows me is the segment-wise insights. So this tells me, hey, network administrator, across your enterprise, there are 400 users who are having a bad performance. And these users are impacted because of these segments. 90 users are impacted due to Wi-Fi, 20 users are impacted due to LAN, and there are 400 users who are impacted due to application web server issues. So this gives me a very clear view on where I should focus on. Is the issue with the enterprise infrastructure, or is the issue within the user's home network? And if there is an issue with the user's home network, where is this happening? Now, you saw the segment-wise insights. I want to call your attention to the right-hand side of the screen, the map. So now you see here, this shows me the global distribution of these 400 users. Where are these users distributed? This also helps me identify if there are any regional hotspots, like, for example, a particular web server in the APAC region is experiencing an outage or a problem, then I would see users in the APAC region highlighted here in red predominantly. So this will also help me identify, okay, so the concentration of users with impacted performance, where are they across my enterprise? Now, as an administrator, I also want to know how the user experience is overall across the enterprise. So this gives me an overall understanding of the end user experience across the organization. So if I see a steep drop in the user experience, it means that maybe something is going wrong with a common service that is consumed by all of the enterprise users, like, for example, DNS or maybe auth server. So this gives me a good understanding of whether my user experience for all the monitored mobile users is consistent or is it fluctuating, and where should I focus my efforts on? Now, for that, the answer to the question, where should I focus my efforts on, is right here. You're looking at a topological view of the entire organization. And this clearly shows you which segment in the organization is experiencing an impact. If it is experiencing an impact, what is the size of the impact? The magnitude of the impact is measured by the number of users who are impacted by that segment. And this also shows incidents that have been raised for infrastructure services that are having a performance impact. So this is what I need to look at every morning when I log into the Sassy Health dashboard. This gives me an understanding of where I should focus my efforts on. What are the next steps? What are my remedial actions that should be taken based on the impact that is going on for each of these segments? Now, similar to mobile users, a network administrator can also get insights into branch office performance. So what you're looking at here is there are 500 branch offices that are connected to Prisma Access. And these branch offices could be any kind of branch office. So it does not have to be a Palo Alto Networks Prisma SD-WAN branch office. These could be any vendor, any third-party vendor. We monitor all of these branch offices, and we are able to call out where exactly the performance impact is happening for these branch offices as well. So similar to what we saw for mobile users, we see these segment-wise insights for branch offices as well. So this provides insights for the network administrator as to what should be the next step. Now, what we are looking at here is the applications tab. So you think of it as a SaaS availability dashboard for your enterprise. These are the business critical applications for an enterprise. And this clearly shows where the performance impact is happening. Now, let's say for this enterprise, there is a performance impact that is experienced with Zoom. Now, when I hover over Zoom, I can see clearly that there is a potential cause that has been identified. And there is also a symptom. It tells me exactly how this problem manifests itself when a user tries to access Zoom application. So there are a lot of users who are blocked, who are unable to connect to the Zoom application. And the root cause has been identified as there is generally an availability issue across several worldwide locations for Zoom servers. Now, I want to drill down into this problem and identify which segment of users are affected, how many users are affected. I need more details about this performance impact and why this issue is happening. So now when I look at this drill down view, I can clearly tell how many users are impacted. And then I can also identify the root causes very clearly called out. It says 35% of the time, the Zoom app responded from a very geographically distant server. So we are looking at a very specific US West location. And it looks like majority of the time, users have been served from a geographically distant server, which is causing a significant amount of latency. There is a natural latency incurred when the service is responding from a geographically distant location. And that explains the slowness that majority of the users are experiencing, and also the reason for session disconnects. So for a network administrator, this is extremely valuable information. So when multiple users are opening help desk tickets, the network administrator already has insights into why this problem is happening. So he can quickly take the next steps necessary in order to remediate this problem. Now, we talked about segment-wise insights. Now, let's talk about the infrastructure services. So I told you that we monitor infrastructure services like DNS, auth server. And this is very, very critical and important for an enterprise because anything with the infrastructure service impacts a large set of users. So for issues that are within the user's home network, the issue is more localized. But when it's an infrastructure issue, that is when things tend to escalate and the situation gets more pervasive and affects multiple users. So this needs to be highlighted and notified to the network administrator as soon as possible. So that is why we proactively monitor critical infrastructure services like the Prisma Access Cloud Infrastructure, data center connectivity, DNS, and authentication server. With all of this monitoring that we are doing, we are able to collect valuable telemetry about the performance about each of these segments. And when we detect an anomaly, we automatically raise an incident. And these incidents can be raised in priority, and the network administrator can be notified based on any mechanism that the network administrator has chosen. It could be a ServiceNow ticket, or it could be any kind of ops tool integration, or even an email alert. So now what we are looking at here is the incident page. So we were able to navigate to this page directly from the mobile user page. We were looking at the 400 impacted mobile users across the enterprise, and we saw the infrastructure services being associated with incidents for data center connectivity. Now, when we clicked on that incident, we were automatically taken to this page. Now, on this page, there is a proactive health incident which shows Prisma Access service connection to a particular site is down. Now, when I open this incident, I'm given details, very, very granular details to understand why this service connection impact happened. Why did this service connection go down? When did it go down? What are the factors that contributed to this service impact? Now, when I look at this incident, first of all, I can see the number of impacted users. So this gives me an understanding of, okay, so what is the size of this impact? How many users are currently accessing data center services via this service connection? So this gives me an idea of the magnitude of the impact. Now, it also gives me details about the impacted objects. So these are the elements that are impacted. These are the data center sites. And then it also tells me the status of this incident. So when was it created and when was it last updated? So I get all of these details. So this last updated is important to know because it gives me confidence that this incident is continuously being monitored by AI-powered ADEM. So we don't stop at just creating the incident. We are continuously monitoring the network situation. If the service connection comes back up, we are going to be updating this incident. If a network administrator acknowledges this incident because this is let's say, happening for a known reason, then in that case, the status of the incident turns to acknowledge along with the user ID of the network administrator who acknowledged this incident. Let's say someone clears this incident, then that status is updated as well. So as and when the status of the incident changes, both from a management perspective and also from a network perspective, this incident will be continuously monitored and the status will be updated automatically. Now, looking at the root cause, the telemetry that we collect around this for this incident, we collect the availability status. So as you can see here, we've been monitoring the availability of the service connection. There were some interruptions in the past, and then there's a significant downtime here. And all of this is historical data that is available. So this helps the network administrator to know if there is any kind of trend that is happening. So let's say the service connection has been intermittently going down, then we would know that, okay, what is a trend? What is there a pattern to this behavior? Now, right here, you can also look at some of the telemetry that we collect around round trip time, user count. So say, for example, the number of users who are connected to a service connection. You can see here in this graph that there is a shaded area, and then there is an orange highlight, and then there is a solid blue line. So there are three colors in each of these graphs. So there's a shaded blue, which refers to the baseline. So we have computed the baseline for this particular metric, which is a user count. And then there is an orange line, which indicates an anomaly. There is a deviation from the baseline. And the solid line indicates the current user count, which aligns with the baseline. Now, this is very, very important because we are adaptively able to learn what is the normal pattern, normal behavior like at your enterprise. Is this your user count? No, is the user count typically around 100 users every Tuesday, 4 to 5 p.m.? We build that baseline for you after 2 weeks of learning your enterprise usage data. Now, anything more than this baseline is considered a deviation from the baseline and an anomaly. Now, this anomaly could typically introduce some kind of service impact in the enterprise, and we automatically raise an incident as soon as we detect this anomaly. Now, this is important because we do not configure, we do not follow predefined thresholds, because a threshold that we define may not be the norm for your enterprise. Your enterprise has a certain behavior, and we want to learn that behavior, and we want to show you what is abnormal for your enterprise. That is why that is the value that baselining and anomaly detection offer. Now, as you can see here, we are also showing correlation of alerts. Now, if you're a network administrator, you know very well the number of incidents and events that are generated when there is a network flap. A tunnel goes down, and then you get like BGP neighborship flaps. And depending on the number of tunnels that particular built on that particular circuit, you get that many number of VPN flap messages. So there are multiple events that are generated as a consequence for a network event. But what does a network administrator really need to know? He doesn't need to see all of these consequences, all of these alerts. All that he needs to focus on is just the single root cause event, this primary service impact. And all other events, the consequences, the child events, are correlated and associated with the parent event, so that the network administrator gets the highest visibility into the most important incident that he should focus on. This considerably reduces alert fatigue and increases visibility to prominent network events that the network administrator needs to focus. So all of this is done as part of the incident management system. And this helps the network administrator quickly get to the root cause of a problem. Now, let's say, for example, an authentication server is behind the data center which had the service connection down incident. Now, normally you would see a separate event for auth service going down, or maybe multiple users are not able to reach the authentication server. And then there are tunnel flap events, and then there are BGP neighborship down events. So all of these incidents would normally be separate entities. Now we are able to associate everything, and we are able to say that, hey, network administrator, your users are not able to access their applications because the auth server connectivity failed, and that happened because the service connection to the data center site was brought down. So I hope this explains clearly how event correlation helps network administrators to get instant visibility into the primary key network event that is impacting infrastructure services and user connectivity. Okay. Now, we talked about infrastructure services. We talked about performance impact that is happening across the enterprise, affecting multiple users. But let's talk about a day-to-day scenario. Let's say user Jane Doe has a problem accessing an application, and she opens a help desk ticket. This is just a regular day in the life of an IT help desk engineer. How does the help desk engineer troubleshoot this problem? So if someone opens the help desk ticket saying, I can't open Salesforce, where does the network engineer even start? For those of you who are familiar with how help desk operates, there are several levels of help desk within a particular team. There's level 1, level 2, level 3. Most cases, because of the lack of visibility, because of the multi-domain analysis that needs to be done, these cases are tossed between level 1, level 2, and level 3. And even in spite of multiple escalations, sometimes issues can never be resolved. And we have to get back to the user with very inconclusive answers. Let us know when the issue happens the next time, or collect this information when this issue happens next time. So this is not a very effective solution. And in general, this affects the productivity of users and is a waste of the help desk team's time. Now, what if I told you we have just the perfect solution to know why specifically a user is not able to access an application or is having limited access to an application? And if all of this could be done in a natural language-based query interface, that's Access Analyzer for you. And this is part of the AI-powered ADEM capability. So what you're looking at here is the Access Analyzer. It's a natural language query interface which helps to identify. You can simply ask this solution, ask this tool a very simple question as to why a particular user, in this case, user Maria Gomez, is not able to access a selected application, Outlook. And the most important thing that I want to call out here is this is not an isolated tool. It is integrated with the Sassy solution, the Prisma Sassy solution. So if you look at it here, when I typed Maria Gomez at paloaltonetworks.com, I didn't have to type out her entire name. Because we are automatically integrated with CIE, we have the user ID information pre-populated. So I just have to start typing Maria Gomez and her name is automatically completed. Similarly, all the applications, and even we have visibility into sub-app level as well. So say, for example, Maria Gomez is able to access Outlook. She's able to upload content, but she's not able to download content from Outlook. She's not able to download attachments. So even to sub-app levels, we are able to frame our queries. Now, in this case, Maria Gomez is automatically prompted as having access issues from Prisma Access location US East. We have hundreds of Prisma Access locations. the query automatically filtered and narrowed down to 2 Prisma access locations because we are tightly integrated with the Prisma Sassy solution. We already know Maria Gomez connects only to the US East and US West locations. So she must be having problem only from one of these 2 PA locations. So we automatically narrow down based on the user ID selected. So these filtered queries make the life of a help desk administrator very, very, very easy because of the awareness that we bring into this particular user's problem. And Maria Gomez has 2 different devices, a MacBook and a second device. And in this example here, the problem that she's having is specifically from her MacBook device. And how do we have this information? Because we are continuously monitoring Maria Gomez as a user, and we know we have insights into the devices that she uses to connect to corporate resources. Now we are going to be submitting this query. So I'm going to customize this query name in an understandable format. So I've changed the name of this query with the ticket ID information, and then we are going to be submitting this query. Now, as soon as I submit this query, it's going to take a minute to complete. And once it's complete, I click on this query. Now, in just less than a minute, I have an answer to get back to Maria Gomez. I know exactly what is causing her app access issue. So if you look at the right-hand side here, you can look at the different domains that this access analyzer tool analyzed for you. So we looked at the endpoint device. We looked at, so when I say we look at the endpoint device, it's the health of Maria Gomez endpoint device. Is her endpoint suffering from performance issues, maybe like CPU, memory consumption, because we have all of this telemetry? Or say perhaps Maria Gomez is having a device posture issue. Let's say she turned off her Windows firewall. She's failed the hip check. So there is a security policy in place which is saying Maria Gomez is now a compromised user who has failed her posture check. So she's automatically limited access to corporate resources. So we look at her endpoint posture as well. We look at her authentication requests and response. If she was able to successfully authenticate with the auth server, how is her DNS resolution happening? Is there any slowness in DNS resolution? How about her application access? What are the different, based on the different telemetry that we collect for application performance and network performance, we are able to say whether there is any issues with application access itself. And then is there any problems with the PA location? Any latency that is experienced in the PA location? Could that be causing her app access issues? And how about data center connectivity? Layer 3 forwarding within the data center infrastructure. Is there any kind of routing issue that is preventing Maria Gomez from accessing the application? And then we also look at security policy checks. So this is also a very common scenario where we've seen Maria Gomez has access to a certain application because her user group is allowed that access. But someone overrode that policy. Maria Gomez is also part of another user group which was denied access to the application. So a security policy override could suddenly block Maria Gomez from accessing the application anymore. So we do that check as well. Now, I want to ask you a question here. So to perform all of this analysis, think about a single help desk engineer who has to do all of this analysis with the user context in mind. He needs to make these checks on behalf of Maria Gomez from her specific device, the MacBook device. It takes a really, really, really long time, or if anything, impossible for a single person to do all of this analysis. Simply because the person may not have the tools or the necessary access or the user context to run these tests. Some of these tests, we may have to involve Maria Gomez in a Zoom meeting and make her do all of these tests. So with the access analyzer, less than a minute, we are able to do this multi-domain analysis. We are able to look at logs and data and telemetry from several sources, keeping the user context in mind all the time. We are doing this analysis specifically for user Maria Gomez, and we are able to identify why this problem is happening. Now, if I scroll down, the access analyzer results show me exactly, that Maria Gomez is having a security policy issue which is blocking her access. So it is very, very clear as to why this issue is happening for Maria, and the help desk team has actionable insights which they can share with the corresponding security administration team or with Maria to rectify the problem and fix it. And not just that, using the access analyzer, the IT team can also run checks like, okay, show me the list of users who are failing HIP checks. Show me the list of users whose devices are having are critical risk are at critical risk. So basically, an IT team that wants to see how many users are not compliant with enterprise security best practices. Example, users turning off AV protection, users turning off firewall. So all of this can be queried directly using the access analyzer tool. So this is a valuable insight for network administrators, and all other capabilities that we covered today with AI-powered ADEM, they significantly help to reduce the mean time to resolve a problem, whether it is for a single user or if it is happening across the enterprise and affecting multiple users. The IT team, the network administration team, the security team, help desk team, all of these teams are empowered with valuable insights to make sure that users are consistently having a good experience and having a very productive day. Thank you so much.